The COVID-19 pandemic introduced a new layer of complexity to credit risk management that deserves specific attention. So increased uncertainty. So traditional credit risk models are built on historical data, trained on patterns from previous recessions, industry downturns, and borrower behavior cycles. The pandemic was unprecedented in many ways. The speed and severity of the economic shock, combined with massive government intervention like furloughs, schemes, and loan deferrals, made historical patterns largely unreliable. Creditworthiness became genuinely harder to assess, and models built on pre-2020 data often produced poor predictions. Also, shift to digital. So while ultimately beneficial, the rapid move to digital-only interactions changed how lenders gather information. So face-to-face conversations that might reveal early signs of financial problems disappeared. Collections and customer service became remote. Banks had to rapidly rebuild their processes for a fully digital context. Some adapted quickly, others struggled with this. And finally, data limitations. During unprecedented events like the pandemic, the data that models need simply doesn't yet exist. You can't train a model on patterns from a once-in-a-century pandemic. This forced institutions to rely more heavily on qualitative judgment alongside quantitative models, and stress the importance of human expertise that no algorithm can fully replace. So, what does good credit risk management look like? Number one, it adopt integrated credit risk solutions. So rather than siloed tools for different loan types or business units, leading institutions are moving toward unified platforms that give a single, consistent view of credit risk across the entire organization. Number two, implement real-time scoring and monitoring. The old model of assessing credit risk once at originations and reviewing annually is no longer sufficient. Modern practice means continuously monitoring borrowing behavior, payment patterns, account activity, external signals, and updating risk scores dynamically to enable early intervention. Next, use advanced analytics for better decision making. This means going beyond simple rules like reject anyone below threshold score and using statistical models and machine learning to make data-driven decisions that account for the full complexity of each borrower's profile. Number four, leverage data visualization for quick insights. Risk managers face data overload. Well-designed dashboards allow them to spot trends, identify concentration of risk, and make faster, better informed decisions without drowning in spreadsheets. Number five, continuous improvement of risk models. Now the world changes and models trained on past data become stale. Best-in-class institutions treat model risk management as an ongoing discipline. So regularly backtesting, recalibrating, and replacing models when they lose predictive power. Now, machine learning has become one of the most transformative forces in credit risk. Let's look at how it's being applied in credit risk management. So four key classifier types are presented here we have logistic regression, which is a classic workhorse. It's interpretable, it's fast, and still widely used for binary outcomes, like questions like will this borrower default or not. Random forest builds many decision trees and combines their predictions, producing excellent accuracy while handling complex nonlinear relationships. Support vector machines are powerful classifiers that work well in high-dimensional spaces. And isolation forest is specifically designed for anomaly detection, which is very important for flagging fraudulent applications or unusual borrower behaviors that might signal an upcoming default. The advantages are significant: high accuracy and the ability to process large, complex datasets with hundreds of variables simultaneously. A well-trained machine learning model can find patterns in payment history, income, employment tenure, geographic location, and spending patterns that no human analyst would spot. The confusion matrix is a fundamental evaluation tool in machine learning classification. In credit risk, there are two types of costly errors: false positives, which predicting default when the borrower would have repaid. This causes you business opportunity because you give up on a loan, and then false negatives, which predict repayment when the borrower actually defaults. So this costs us the business money. Every credit model involves a trade-off between these two error types, and the confusion matrix makes that trade-off visible and manageable.